Hello everyone, Namaste. I am Munakahar, teacher of Joint School Family, and I am continuing your Class 8 Science subject. Okay, so let's start today's class. So our today's topic is molecular formula. Okay, so what does this molecular formula means? Okay, so molecular formula is your short and abbreviated form for the full name of a molecule of a substance is called molecular formula. Okay, to represent a molecule, okay, to represent a molecule, it's writing them in a full name is better to write them in a short form, okay, or the abbreviated form, okay, and that we call as molecular formula. Okay, it is just the representation of a molecule in a short form. Okay, so molecular formula is the representation, okay, or the short and abbreviated form of a molecule. Okay, so it shows the actual number and kind of atoms present in a molecule of a substance. Okay, it shows so how many number of atom, okay, or molecules are present there in a substance. Okay, so it shows the actual number and kind of atom present in a molecule of a substance. For example, if I say H2, so what is the meaning of H2? It is a molecule of a hydrogen. Okay, it is a molecule of a hydrogen. Similarly, NH3, what is the meaning of NH3? So NH3 is a molecule of ammonia. Okay, similarly, if we talk about H2 and 2H, what is the meaning of H2 and 2H? So H2 represents your molecule of a hydrogen, or it is the molecular formula of a hydrogen. Okay, H2 means your molecule of hydrogen or the molecular formula of hydrogen. Similarly, 2H means what then? So 2H means it represents your two atom of hydrogen. Okay, simply 2H represent two atom of hydrogen. H2 means your molecule of hydrogen. 2H means two atom of hydrogen. Is it clear? So now we are going to do some of the or learn some of the rules to write the molecular formula. We are going to see how we can write the molecular formula. There are some rules that we should follow while writing the molecular formula. Okay, so now let's talk about that. Your first rule is write the symbol of element or radical side by side. If one of the constituent of a compound is metal, then write it first. Okay, so we should know who are going to react there. Okay, so what we have to do, we have to write down the name of that element or radical side by side. Okay, it is the first rule. Which two elements, okay, are going to react, we should write them side by side first. Okay, which molecular formula we are going to make, okay, we have to write them side by side. For example, hydrogen and oxygen, suppose we are going to write the formula, a balance formula for your hydrogen and oxygen. Okay, so what I have done, I have just written the name of hydrogen and oxygen side by side. Okay, after that you write down the symbol for hydrogen, that is your H, and for your oxygen, that is your O. Okay, so now what is our second step? So I am going to erase this, okay, so that I can write the steps here. Please you all uh, concentrate. Our second step is now write down the valency of an element or radical at the top. So after writing the name of element or radical side by side, like here hydrogen and oxygen I have written here H and O. After that what we have to do is we have to write the valency at their top. Second step is write down their valency at the top. First step, write down the name of that element side by side. Okay, after that write down their valency at their top. For example, for your hydrogen and oxygen, the valency of your hydrogen is 1 and the valency of your oxygen is 2. Okay. So now third step is interchange their valencies. So next step, third step is your interchange their valency. Okay. So what is here? Hydrogen and oxygen. Hydrogen valency is 1 and oxygen valency is 2. Okay. So we are going to interchange. If you prepare your book, then there may be written as interchange their valency by drawing an arrow diagram. Okay. I am showing here by arrow diagram. So interchange them. This one valency will be taken by oxygen and this valency of oxygen, that is your 2, it is taken by your hydrogen. So what it will becomes? H2O. Okay. So what is it? H2O means what? It is your H2O means your, actually this balance has gone 1 and this 2 has gone here. Hydrogen has taken this 2 and oxygen has taken this 1. So 1 it will represent. Okay, so I am not writing here 1. Okay, so H2O means your, it is your molecular formula of water. Okay, so let's see once again. What we have to do is, while writing the molecular formula, we have to write down the name of element or radical side by side with their symbols. Okay, after that we have to write their valencies of that element or radical at their top. Okay, after that we have to interchange their valencies. Okay, we have to just interchange their valencies. Okay, then we will get H2O. Suppose here we got H2O. So this is your molecular formula for water. Okay, so sometime one more rule is there. Sometime what happen, if the valencies are same, suppose your fourth step is, if there is common valency, then remove it by taking common. So I am going to erase this first step. I hope you have understood this first step. In first step is generally simply write down the symbol side by side. Okay, so I am going to erase it. First step here. So your fourth step is, if there is common valency, then remove it by taking common. For example, suppose there is magnesium and oxygen. Okay, the valency of magnesium is 2 and oxygen is also 2. So what will happen now? If you interchange, you will get here Mg2O2. Okay, so they have common valency. So what we have to do? Take common and remove it. Okay, so what we will get here? That will get MgO. Okay, MgO is your magnesium oxide. And what does it mean here? Here it is your due to the same valencies, okay, due to their same valencies, okay, what we have done, we have taken common, okay. This spelling is MagNesium, magnesium oxide, okay. So this is the molecular formula for magnesium oxide, okay. This is your fourth rule, okay. So some more example let me give you. Some more example like here, sodium, for sodium chloride, for your sodium chloride, your sodium and chloride I am writing here. Valency of sodium is your 1, okay, and your chloride is also your 1. So if you do cross, sodium is your actually Na and chloride is your Cl, okay. So you will get here NaCl. Is it clear? Let's see another example. Hydrochloric acid, for hydrochloric acid. So here it is a hydrogen and chlorine. So valency of hydrogen is 1 and chlorine is also 1. So if you do crisscross, just cross it, then what you will got here, that is your HCl, okay. Similarly, for your sulfuric acid, your hydrogen and sulfate will react. For your sulfuric acid, your hydrogen and sulfate will react. For your hydrogen, your symbol is H, and for your sulfate is your SO4. Okay. So for your hydrogen, its valency is 1, and for your sulfate, its valency is your 2. So just interchange it. You will get here H2SO4. Okay. So these are the some of the molecular formula, okay. And in your book, okay, in your textbook, in your page number 154, okay, the name of some radicals and their valencies are given. Like here I have used the sulfate here, okay. In your book it has given like your chloride. I am just going to read some of the name of radical and their valency, okay. Chloride, its valency is 1, its symbol is Cl, okay. Hydroxide, its symbol is OH, okay, and valency is 1. So in page number just 154 in your textbook, you can easily find some of the radicals name and their valencies, okay. Likewise your sulfate, its valency is 2, okay. Phosphate is valency PO4, okay, its valency is 3, like that. You can see some of the name of radicals and their valencies, okay. Please prefer your book and read your book also, okay. And I hope today's class you all have understood. So thank you for today's class. Thank you everyone. Stay home, stay safe.